Okay, in this lesson, we're going to look at linear translations. Our essential question is explain how to identify the different types of linear translations. If you'll please take a minute, pause your video, set up your notebook, and get ready to go. Okay, the first thing that I want to tell you about is the linear parent function. This is really important because all of the transformations that we talk about, one of the things we're going to be doing is comparing it to the linear parent function. Now, the linear parent function is simply f of x equals x, or another way to think of it is y equals x. So notice it's a very simple, basic linear equation, and that's why it's the parent function, linear parent function. Because, and this would be a definition you could include in your vocabulary, it is the most basic linear function. Okay? If we were to look at those equations, we would identify its slope as being 1 and its y-intercept as being 0. So that's really important. You need to know that. And so then today we're looking at linear translations. And so you should recall that when we translate something, we are sliding things around side to side. And so we're always going to be adding or subtracting. So when you see something that's being adding or subtracting, that's your clue that it's going to be a translation. Okay, and somebody's knocking on my door. Okay, so we have two rules here. We have f of x minus c, and we have f of x plus d. So two different types of translations. Okay, the first one is a horizontal translation. Okay, and the reason I know this is a horizontal translation is because it affects x. So what I want you to see right here is, do you see how this is in parentheses, the subtraction? We know that x is in parentheses. It's affecting the x. And so because it's affecting the x value, we're moving, we're sliding, we're translating left or right. Now I'm going to cross this out because I think this is a little confusing. If, in parentheses, it says x minus a number, your instinct is going to say that the graph shifts left, but it actually shifts right. And I want you to think about that. Our rule is x minus c. So if c was positive 3, when I plugged that in, it would say x minus 3. So see, we really put in a positive number, and we're really saying shift 3 units right. But it has that minus. That's just part of the rule. So for the next one, if you have x plus a number, then that's actually going to mean that our graph is shifting left. Because again, let's say that c was negative 3. And if I put that into my rule, see how that turns into a positive? Okay, so that's a little tricky, and we're going to talk about in class how we can also use our calculators to help us with this. And so C is telling us how many places our graph shifts, left or right. Okay, in the other rule, notice I'm telling you that this is a vertical translation. Basically, all we're changing is the y-intercept. That's where our y-intercept. This is a vertical translation because it affects the y, or the f of x. Okay? So again, if the d is a positive number, the graph is going to actually shift up. And if d is a negative number, the graph is going to shift down that many units. So it should be pretty simple. Okay, so what I want you to do is I want you to pause the video for a second, and I want you on each of these graphs to go through and graph your original function. So these functions that I'm highlighting, I want you to pause the video and take a minute to graph those. And then when you're finished, restart the video so we can look at the transformations. Okay, so the first transformation we're going to look at. So we have our original graph f, and I want to translate it so that we are doing this. Now it says x minus 4. So we know, according to what we set up here, if it's x minus a number, that means our graph is going to shift right. So we could say that our graph is translating right 4 units. So the graph can be really helpful. So now that we have our original graph, we're going to actually draw graph G, and I'm going to shift it 4 units to the right. So I'm going to pick this point right here, and I'm going to go 1, 2, 3, 4, and put a new point. And then I could do the same thing. I'm sorry, the lines are hard to see. 1, 2, 3, 4. Now what I want you to see is the slope didn't change. So I could translate each point like I'm currently doing, or if I know my slope is 2, then I could use my slope to draw more points. So from here, I'm going to go down to left 1, down to left 1. And I'm losing my place. Left 1. And the reason that I need to keep doing this is because, and I think I got off a little bit, I need to be able to write the new function. Now, if we're going to write the new function, we need to know what the slope is, and we need to know what the y-intercept is. So our new function g, it has the same slope of 2x, but notice our y-intercept is now -9. So a couple of other things that I want us to notice here is that not only did it translate right 4 units, our x-intercept, or we could say that our x-intercept moved right, and we could also say that our y-intercept moved down. Notice the steepness of the line is the same because we did not change our slope. Okay, let's look at the graph to the right. We already have function f graphed, and so now we're going to graph function g. Because our rule says f of x minus 6, we know if we have a negative number, that means that our y-intercept is going to translate down 6 units. Okay, so we can look at our points and we can count down. 1, 2, 3, 4, 5, 6. Okay, I could do that for every point. 1, 2, 3, 4, 5, 6. Notice my slope is 2. I could also use my slope. Up 2, right 1. Up 2, right 1. Up 2, right 1. Okay. So not only did our graph translate down 6 units, our x-intercept also moved right. Okay, so our new function, we have to know our slope, we have to know our y-intercept. Our slope is still 2, and my y-intercept now is -5. So our new function is g of x equals 2x minus 5. Now, I don't want to continue going through these notes together because I don't want you to get bogged down. I do want you to look at the last 2 examples yourself, and I want you to see if you can decide, what does this rule say we're going to do? How does this say we're going to translate? How does this graph say we're going to translate? And see if you can kind of think about those 2 problems on your own, and then we will pick up with those tomorrow in class together.